Inside the box here, we have our 3 properties listed. These are the ones that we're going to be using to do what's called expanding and condensing logs, like taking them apart using the properties or putting them back together using the properties. The first property is just called the product property. Again, exponents have these same properties, radicals have similar properties. So when you have a log of any base and there's some sort of product in the argument, n times n, whenever you expand it to take it apart, it's going to turn into 2 separate logs that are being added together. 2 separate logs that are being added together. So one of those logs is going to be log base b of the first, what do they call them? Factor. The first factor in the product. There we go. Okay. And then that's going to be added to log base b of the second factor in the argument. Here we go. So this first form here is called the condensed form. Bless you.
Thank you.
Condensed. The second form is called the expanded form. In condensed form, the word log is only written 1 time. In expanded form, the word log could be written several times, especially if you have more factors in this argument here. So say you had 3 or 4 things being multiplied, and you'd have 3 or 4 different logs out here. Second one's called the quotient property. Quotient because there's some sort of fraction in here, some sort of division. If multiplying turned into adding when you're expanding, what do you think a fraction is going to turn into? Subtraction. Very good. So if we have log base b of n divided by n divided by m, that'll turn into log base b of the numerator, which would be the top of the argument, minus log base b of the denominator, which is the bottom of the argument. Okay, and then lastly, our third property is called power property. Power referring to an exponent. If you have log base b of n to the power of m, so there's some sort of exponent on it. That's what it looks like in its condensed form. Yes, it actually does turn into multiplying. So you're going to actually take the exponent, and it can come out front and be multiplied by log base b of n. So the exponent is going to come out front basically as a coefficient. And so we're going to be using our properties of logs to expand each of the following. Okay, so remember, these are the condensed form. We're trying to expand it, which means that the word log is going to be written multiple times. And so first thing I notice on the first one, we have log base 2, and then we have a fraction that's in parentheses. So if I have a fraction in parentheses, the first property I want to use is the quotient property. I want to split it up into 2 separate logs where we have the numerator and denominator separate. So that's going to split into log. You're going to keep the base the same. And then my first log is going to have 5x numerator. And then we'll have minus log base 2, and then we'll have our denominator for our second argument. It's usually helpful just so people know where the argument starts and stops. Now, one of these actually does expand further. So it has more than one property that we're going to use to expand it. Can y'all see which one needs to expand further? Which one? The first one, yes. This one needs to expand further. And the reason it expands further is inside that argument, there's a product, which means we can use the product property to take this one and expand it further into 2 separate logs. Okay, so reminding ourselves what product property expands into, it expands into 2 separate logs being added together of the first factor times the second, or the first factor in the first argument, second factor in the second argument. So that one's going to split into log base 2, and then we'll put our first factor, which is a 5, and then plus log base 2 of the second factor, which is x, and then we're just going to bring down this back one here, minus log base 2 of y. Okay, and then I'm just going to check each argument. I just want to make sure I don't have any exponents, I don't have any fractions, I don't have any more products in those arguments. So this looks like a good answer. That is, yes, expanding makes it more complicated. Yes, condensing makes it simpler. Okay. Looking at the second one, log base 3 of 9 times the square root of x over y. Okay, so again, first thing I notice on this one, it has that big fraction. Anytime you have that big fraction from the start, I would start by doing the quotient property and saying, well, I need to split this up into 2 separate logs where we have the numerator and denominator as 2 separate logs. So my 2 separate logs are coming now. Log base 3. In my first argument, I'm going to put the numerator, 9 square root of x, bless you. And then plus or minus? Minus, because we have the quotient property, good. Log base 3 of our denominator. Okay. Now, again, one of those can expand more. Can we see which one needs to expand more? The first one again, because inside that first argument, we have 9 times the square root of x. And that means it's a product, and products can expand more. So this first log is going to expand more. Okay. So that's going to split into 2 separate logs that are being what? According to product property. 2 separate logs that are going to be added. Perfect. So the first one will be log base 3 of 9. Okay. Added to log base 3 of square root of x. And then I didn't do anything to this back one, so I'm just going to bring it down. Minus log base 3 of y. Nope. There's actually 2 more things we can do on this one. Okay. Well, you want to get it right or you want to get it wrong? Okay. So first thing I noticed is this says square root of x. Now, technically, square root of x is x with what power? Nope. 1/2. 1/2. Right. This square root of x is actually, I could rewrite that as x to the power of 1/2. Okay, now the reason that's important on this expanding logs question is because it technically has an exponent. And if it has an exponent, that means I can do the power property. Okay. So I need to take this exponent on the x, and according to power property, I need to bring it down in front of the log. You're basically taking the exponent and moving it down in front. So I need to take that 1/2 and I'm going to move it down in front of its own log. So we'll have log base 3 of 9 plus that 1/2 is going to become a coefficient according to the power property. 1/2 log base 3. Yes, technically this is 1/2 times. Good job. And then what's in the argument still? X. All we moved was the exponent. Good. Minus log base 3 of y. Okay, Mason, ask your question. Is that the answer? Not quite. There's one more thing we got to do. And it's not even a log property. It's not even one of these. There is one of these that has an actual answer. One of these can simplify. Yes. Log base 3 of 9. Remember what that means. That means 3 to the what power is 9? 2. So this whole thing actually just turns into a 2 because it has an answer. This whole thing is going to say, oh, okay, well then, that's just 2 because 3 to the second power is 9. So now my final answer, 2 plus 1/2 log base 3 of x minus log base 3 of y. Now this is the final answer. Yes, I'm.
If you were to forget this, so 1/2 that could make an answer. Okay.
Just writing it in front means times.
Never mind. Instead of 2, that'd be wrong.
You left it like this?
Yeah.
So you would probably get it partially wrong. Not entirely wrong. But partial credit. Okay, looking at our third one. Again, we're starting with that big fraction. So what's the first property we're going to use? Quotient property. We got to split it up into log of the numerator, 2y to the fourth, plus or minus? Minus, good job. Log of the denominator. Why is there no base on this log?
10.
Because it's a 10. What type of log is that called? Common log. Good memory. Okay. Each of these now, if you look at those two arguments, in each of those arguments is what? A product. In each of these arguments is a product. The first product is 2 times y to the fourth. This second product is 10 times x squared. So both of these are going to break down into 2 separate logs.
Because it has a y.
We'll get there. That'll be our next step. But right now, we're just going to break it down into, this one's going to split into log of the first factor, which is a 2, plus log of the second factor, which is a y to the fourth, minus, okay, it's going to get a little tricky here, guys. We're subtracting, but we are going to have 2 separate logs here. Anyone know what I'm going to have to add to this if I'm subtracting 2 separate logs? You either have to subtract both, or you need to put subtracting and then a parenthesis to show that you're subtracting, and there's going to be 2 separate logs. So we'll have log of the first factor, which is 10, plus log of the second factor, which is x squared. So we had to put the parentheses here because we had 2 things that this log turned into. So your other option is to just take this negative and distribute it and write minus on both. So you remember they were both minus. Okay. Do we still have, we don't have any more products in the arguments, but what do we still have? More work to do. We don't have products, but what do we do have? Powers. We have 2 logs that have powers. So on those 2 logs that have powers, we need to take that exponent, and where does it go? Down to the front as a coefficient. Down to the front of that log as a coefficient. So I'm going to have log of 2 plus, and then for this one, I'm going to have 4 times the log. And what's the argument still? What's still in my argument? Y minus log of 10 plus, and we're going to move this exponent as well, 2 times log of, my argument is still an x. Anyone know the one more thing I got to do? Do you know it, Sean? Yes, this one simplifies. Because remember, technically, log of 10 means log base 10 of 10. And log base 10 of 10 means 10 to the what power is 10? 1. 10 to the first power is 1. So this whole thing right here has a value of 1. It is. Wow. Good job, Anna. It is. It's a different way of writing an exponent. All right.
Just more time inside of
We have log 2 plus 4 times log of y minus parenthesis 1 plus 2 log of x. If you wanted to, you could take that negative and distribute it to make it even cleaner, but you don't have to. All right, looking at our fourth one, what are we going to start with?
Wait, you're gonna start with the quotient.
The quotient thing, yes. All right, starting with quotient thing. Can I move it, Nathan? Yeah.
Are they like like when you they go on the one side of the
Kind of, they're like inverses of each other. We've learned that already. All right, I'm going to use my quotient property to split this up into ln is technically, what's its full name?
Logarithm
Natural log. Good. Natural log. So I'm going to have natural log of my numerator, 10e to the 11th power. Quotient property says that's going to turn to subtracting natural log of my denominator. Which one of these splits up further? The 10, because there is a product in there. There it's 10 times e to the 11th. So, which means this one's going to split up more. Product property turns into adding when you expand it. So we'll have ln of our first factor, which is a 10, plus ln of our second factor, which is e to the 11th power, minus our natural log of 9.
What means that's one of the
All right. We have either 2 or 1 more step, depending on the way you look at the next problem. We have either 2 or 1 more step.
the E.
Okay, so this right here still has a power on it. You know that. Oh, Thorn, does Thorn know how I can turn the 2 steps on this one into 1 step?
Doesn't the ln just signify log base e?
Yes, ln does mean log base e.
And the back to 1.
Cancel them out. This right here, natural log of e, those are inverses, they would cancel. Log base e of e would cancel and leave me with just what? 11. Just a regular old 11. So I'll have natural log of 10 plus regular old 11 now, minus natural log of 9.
Yes.
What? We have learned this already. Yes.
We're totally limiting. Just like we know that you have all these little word thingy problem.
Yes, it means natural log. Okay. Next section, we're going to go backwards. Right? We are condensing these. So at the very end, the word log should only be written 1 time when you condense. Or 1 time. Technically, this first one is actually already partially condensed because we already have the product together in this one argument. So there's really only one more thing that I need to do to condense this. 4 goes back to be the exponent. Good job. So this power, or this coefficient here, goes back to being a power. So that'll give me log base 6 of 3x to the 4th power. If you want to, you could simplify 3x to the 4th power. I'm not going to bother with it. Like you could do 3 to the 4th, x to the 4th, which is 81x to the 4th, if you wanted to. I don't feel like it though. Looking at the second one. Okay, second one again is already partially condensed. Okay. So if we're thinking about the order that we normally expand in, we normally do quotient property first, and then we do product property, and then we do power property. We're going to kind of do that opposite now. If I normally do quotient property first, and then product property, and then power property, I'm going to start by doing my power property. What power property could I do here? A 3. It's a coefficient. We're going to put it back as an exponent. Pay attention, gentlemen. Why does the exponent say it again? You could put it inside. You could say log base 6 of 3 to the 4th x to the 4th. If you wanted to, and then simplify it. It doesn't matter. All right, let's see. Natural log of 3x. I'm going to put that coefficient back as an exponent. 4x plus 1 to the 3rd power. Okay. I have us adding. Adding recombines, condenses to what? Multiplying. So that means we're only going to write the word natural log 1 time. And we're going to have these 2 arguments multiplied together. This and this multiplied together. And here's how I'm going to show that. 3x times 4x plus 1 to the 3rd power. Okay, is Miss Brody gonna make you multiply this out 3 times and then distribute your 3x? No. Leave it just like that, because technically we wrote it as a product. 3x times this, we did.
Outside the pond. No, it's about that.
Alright. So again, we normally start by doing quotient property, product property, and then power, so we're gonna reverse that. So we're gonna start and look for any powers. Do I have any things that need to go back and be powered? A 2, yes, I got that 2, that's the coefficient here, that needs to go back up here. Log base 2 of 7 plus log base 2 3y. No, if the 2 was in the argument, it would cancel out. Log base 2 of 12x. Okay. Then what? What would I condense now? Would I do that first?
Or yes, you were.
I would not do the quotient property next. What would I do next?
Where?
The power. No, we just did power.
The other one.
They're listed on the top of your paper. Product. We're going to do product next. These two are going to condense into, you're just going to write the word log base 2 one time now. And what happens to the two arguments? They get multiplied together. 7 times 3y squared. Minus log base 2 of 12x. Okay, now what can I do? Now I can do my quotient property. Very good. Again, you are only writing the word log one time. So we're going to write log base 2. Okay, and then we're going to have a fraction. What's on the top of my fraction? No, not 21y squared. Let me show you what it would simplify into if you were wanting to simplify it. You would have 7 times 3 squared, which is 9y squared. So that would turn into 63y squared. If you wanted to simplify it, it would be 63y squared, or you can just leave it as 7 times little parentheses 3y squared. Okay, and what's on my denominator? 12x. Let's look at that last one. That one's looking weird. Now, I'm going to start by simply just taking that 2 and distributing it to get rid of that big parenthesis and just making it a coefficient on all of them. Okay, so that'll give me 2 times log base 5 of 4. And then 2 times a half would turn into what? 1. So I don't have to write the coefficient anymore. I can just write plus log base 5 of x minus, and then we'll have 2 times log base 5 of 3y. So that got rid of our big giant parenthesis. What should we simplify next? The powers. Right. I'm going to start by putting any coefficient back as an exponent. So this 2 is going to go back and be an exponent, and this 2 will go back and be an exponent as well. And so we'll have log base 5 of 4 squared plus log base 5 of x minus log base 5 of 3y, that whole quantity squared. Okay, got that. Then what? Yes, the adding becomes multiplying. What property is that? Product. These two are going to condense into one log base 5 of these two arguments being multiplied. This first one's really easy to simplify if y'all want to do that. So if I multiplied these two, what would I get for my one argument? 16x. Where did W come from?
Oh, no, it's squared. It's W.
W.
That's an X.
That is an X.
Okay.
Okay, and what's my last property? Quotient, right. So again, it's going to turn into 1 log base 5. And now we're going to have a fraction. What's on the top of the fraction? 16x, my first argument. What's on the bottom? Yes, you can write 9y squared, or you can write the quantity of 3y squared.
It's so easy.
Really? 4w?
Oh, look at the bag.
No, the back's easier than the front, I promise you. The back's a billion times easier than the front.
Well, I feel like how we doing this shit.
Well, maybe a little. Okay. Suppose we already know we're given two values. We're given that log base 6 of 5 is 0.898, and we're given that log base 6 of 8 is 1.161. You can actually use your properties to evaluate these. So if I have log base 6 of 5/8, I can use my quotient property and say, well, that's log base 6 of 5. Quotient property, remember, turns into subtraction. So minus log base 6 of 8. And then I know the values for each of these. They told us log base 6 of 5 was 0.898. They told us log base 6 of 8 was 1.161. And then if I subtract those two,
Oh.
I get negative. Liam, will you tell us since no one else wants to? I didn't hear because I was listening to you. Negative 0.263. Good job. Okay. Log base 6 of 40. But remember, I'm only given a 5 and an 8 in the argument. What should I do first? In the what? What, Mason? 5 and 8. Good job. Log base 6 of 40 is log base 6 of 5 times 8. Okay. And then a product splits up into what when we expand? Product splits up into two logs that are being added. So we'll have log base 6 of 5 plus log base 6 of 8. And then again, we know both of those values. We know log base 6 of 5 is 0.898. And we know log base 6 of 8 is 1.161. And if I add those, I get 2 points.
0.0.
Perfect.
No.
Let's see if we can use the power property on this one. I'm going to see if I can use the power property. How can I rewrite that 64 with one of the arguments I already have? Yeah, log base 6 of 8 squared. Okay. And then that exponent is going to come down to the front and become 2 times log base 6 of 8. And we know the value of log base 6 of 8 is what? 1.161. So it's just 2 times 1.161. Perfect. Good job. I told you the back was easier than the front. All right, and then lastly, we have one more. It's kind of a property. It's not really a property in the sense of like expanding and condensing. Change of base formula. Okay, it's really easy. Don't stress. So if you have a log with any base of any argument, you can rewrite that log using any base of your choice. B stands for any base of your choice of A which was your original argument, over C, which was your original base. Now, the easiest base to use, if you have a choice of bases, the easiest base to use is usually base 10. Yeah, because base 10, number one, you don't even have to write the base if it's base 10. And there's a very nice handy button right here, log, that is a log with base 10. Okay. So what I usually do, instead of writing it log base B of A, I just write it as a common log of A. A stands for your original argument, divided by a common log of C. C stands for your original base. Original argument, original base. Let me notate that. Original argument, original base. Okay, so if I wanted to rewrite these logs using change of base and rewriting them with a common log, base 10, I would have a common log on the top, a common log on the bottom. What's the new argument of this common log going to be? 20, because that was my original argument. Okay, and what's the new argument of the bottom one going to be? 3, because that was my original base. I'm going to grab my calculator. We're going to use the common log button, which is 4 up on the left. You don't have to, there's no base because it's base 10. So you're going to type log 20 divided by log 3. Everybody grab a calculator and practice just so you know how to do it. Yeah, I usually do. Log 20 divided by log 3, and you get an answer of 2.73. Oh, you didn't close your parentheses? Yeah, you gotta do that. Apparently. Okay, so for the second one, if I have log base 8 of 100, I'm gonna rewrite that with 2 common logs instead.
If we're gonna use the calculator, why don't we put the original one in one?
Yeah, do that, Danny. Do that. See what you get. Do it, Danny. Show us. Show us, Danny. Show us. Show us how to do it, Danny. Okay. What's my new argument here? 100. What's my new argument on the bottom one? 8. Technically, one of these you already know the value of, but technically we know the top one has a value of what? 2. 10 to the what power is 100? 10 to the second power is 100. But let's see what our decimal equivalence is. Log 100 divided by log 8. 2.21 approximately. No, you don't need to know how to do that. You need to know how to use change of base. Change of base is written like this, Dan. That's what's different about it. Technically, you don't even need to know how to do decimal equivalent. You just need to know how to use change of base. Okay. We're rewriting this one with 2 common logs. What's my new argument for the top one? 141. What's my new argument for the bottom one? 1.6. If we wanted to see what it looks like as a decimal, 10.53 approximately.